Every business eventually collides with a hard mathematical limit, the sheer lack of hours in a single workday. As a customer base expands, the volume of routine inquiries, questions about operating hours, inventory levels, or contact information, scales up with it. Handling these repetitive questions consumes resources, pulling highly skilled employees away from the specialized, revenue-generating tasks they were actually hired to do. To clear this operational logjam, systems architects deploy automated agents, commonly known as chatbots. A chatbot functions as an active, cloud-based intermediary capable of executing dynamic database workflows. The core motive for integrating this automation is strictly structural, recovering hours of human labor and reallocating it to higher-value operations. At a technical level, the primary function of a modern chatbot is to bridge the chasm between a user's messy, unstructured request and a rigid, structured back-end database. To grasp exactly how these agents accomplish this, we need to map the precise path a piece of data takes from the initial human input down to the final system execution. We can observe this architecture in action by tracking two contrasting models: a simple open retail inquiry and a complex, highly secure banking transaction. Deconstructing these models reveals the specific computational layers required to translate raw conversation into actionable database logic. The data journey begins at the input layer, where users submit requests across a fragmented array of channels, including website text portals, direct voice calls, and instant messaging platforms. This creates an immediate architectural hurdle. Human language is inherently imprecise, full of slang, irregular syntax, and highly variable phrasing. In computing terms, this is unstructured data. Traditional relational databases, which rely on strict rows and columns, cannot directly interpret a conversational phrase. The system requires a translator, which arrives in the form of natural language processing, or NLP. Hosted in the cloud and driven by artificial intelligence algorithms, the NLP layer dissects the raw audio or text input to identify the user's specific intent. It extracts the relevant variables from the conversation, like a product type, color, and quantity, and binds them into rigid logic parameters. This entire translation process executes in milliseconds within the abstracted cloud layer, readying the payload for routing. The NLP layer converts chaotic, multi-channel human input into the exact syntax a backend server requires. To see this routing in practice, we look at our first model, a standard retail bot managing a floral shop. A customer submits a simple request, asking if the shop has a dozen yellow roses in stock. The input hits the cloud NLP layer, where a dozen yellow roses is instantly translated into the parameters quantity 12, item rose, and attribute yellow. The chatbot service provider takes this packaged query and directly connects to the shop's back-end inventory database. Inside the server, the system runs a deterministic logic check. It compares the requested volume of 12 against the current on-hand inventory, which sits at 36. The real-time stock data satisfies the mathematical threshold of the request. The database generates a positive response packet and sends it back out. The cloud layer receives this confirmation, translates it back into natural language, and pushes it out to the customer's interface. The shop owner continues building floral arrangements, entirely unaware that a customer inquiry was just received, processed, and resolved. This model succeeds by executing rapid, deterministic logic checks against open, non-sensitive data. Architecture changes entirely when the data in question is no longer open to the public, as seen in our second model, a banking bot. Here, a user interacts with the system to request their specific checking account balance. The NLP layer successfully processes the intent of the request, but the routing encounters a hard stop before it can reach the database. Financial records are heavily secured. The system is programmed to deny all blind queries. Unlike the seamless flow of the floral shop's open inventory, this architecture demands a stateful pause in the transaction to verify the user's identity. The bot suspends the initial query and initiates an authentication loop, prompting the user to supply identifying credentials. It asks for specific, strict inputs, such as an account number, date of birth, and a private PIN. The user provides these details via their secure interface, feeding the exact required variables back into the network. The cloud layer packages these credentials and delivers them directly to the banking server's locked gate. The bank authenticates the provided variables against its internal records, confirms a match, and unlocks access to the core database. Only now does the system execute the original query, extracting the specific, sensitive payload of the user's account balance. The system encrypts this response, routes it back through the intermediary cloud layer, and delivers it to the authenticated user. Protecting sensitive data within an automated framework requires building iterative authentication loops directly into the data path before any database query executes. Despite the differing security protocols, both the retail and banking architectures share a critical trait. The entire loop, from user to cloud to database, functions completely autonomously. Historically, constructing these multi-layered systems required deep software engineering expertise to hard-code the NLP algorithms and secure API routing gates. Modern chatbot services solve this through infrastructural abstraction, burying the complex syntax underneath the user interface. Cloud providers pre-build and maintain these intricate data pathways, eliminating the need to write custom code for basic implementations. Building a functional agent now simply involves outlining the operational logic and providing conversational instructions, like telling the bot to inform users that the shop is open from 9 a.m. to 6 p.m. Because the heavy architectural lifting is maintained by the cloud provider, advanced automated logic is highly accessible to virtually any organization. This layer of abstraction enables rapid deployment. An organization can outline its logic, configure the natural language responses, and deploy a fully functional bot in less than 60 minutes. Within that single hour, a business successfully spins up enterprise-grade NLP, multi-platform input translation, and direct database routing. This rapid deployment cleanly resolves the operational bottleneck that limits a growing company. Every automated interaction contributes to a compounding return of time. Because the labor cost for the bot remains fixed, while query volume can scale indefinitely, the total hours reclaimed for the workforce grow more significant with every query. Chatbots function as structural architectural layers that automate logic, secure data, and systematically reclaim human operational hours.